Yes.
Now see, in the last class, what I had said to you that we were actually watching the summation of the two vectors, and we what we were doing that for to add up the two vectors, we had what were having we were having that the initial vector was somewhere, and the second vector that we were taking, we have to coincide the tail of the second vector with the head of the first vector. Yes or no?
Yes.
Okay, so only then we were going to achieve this particular figure. Yes or no? So that means I need to shift the A in this side. Only then I can find out the magnitude. Yes or no? And for the angle, what I need to do? Do I need to shift the vectors?
No.
Yes. Okay. Let's take a very fresh thing and then ask to you. Let us assume that this is our A and this is our B, the two vectors that I had given to you. Now tell me, I want the R vector to be A plus B. Now, what will be the first thing that you will do?
Head of R to tail of B.
Yes, you will first of all move the A. So let's move it. Let's keep it here. So we had moved it. Now next, what
Resultant
will be
vector
the
diagonal.
Yes, that will be this. Okay, so we had seen this. So this was the resultant vector. And after that, you will use this formula, but while applying this formula, you need this theta also. Yes or no?
Yes.
So from where you are going to find out this theta, this particular theta?
Extend A.
Extend A. That means now again, what do you want? You want to shift the A in such a way that its tail should coincide with B. Yes or no?
Yes.
Okay, so that means we are facing a problem here. What the problem is that for to find out the angle, we need some different orientation of the vector, and for to find out the resultant, we need some different orientation of the vector. Yes or no? Are we facing this particular issue or not?
Yes.
Yes, we are facing this particular issue. So for to just get ahead of this particular issue, we had used the different technique of the addition. That I'll tell you, that is a very easy part, but I'll let you know, and then we'll move ahead with the further topic. That is the parallelogram law of addition. What does parallelogram law of addition says? For the parallelogram law of addition says that you just need the two vectors to be kept like that, the tail of the two vectors should coincide, somewhat like this. Okay, understood? If this is A and this is B, just only this orientation is required. If this is A and this is B, are we very much in a very good position to find out the theta? Yes or no?
Yes.
Yes, we are in a very good position because this is the only thing theta that is required to us. So this is the theta that we are getting it from here. But and what is the next thing that we want? The next thing we want is the resultant only. Yes or no?
Yes.
So for to find out the resultant, what the parallelogram law says that you had got the two sides of a parallelogram, just complete the full parallelogram. If it is required to complete the full parallelogram, what I'll do, I'll make a parallelogram using these two lines, and that parallelogram will look somewhat like this. Yes or no? Will it look like this or not?
Yes.
And the final resultant will be the diagonal of this parallelogram. Is this clear to you?
Yes.
This is the final resultant that we are going to see. And also we had used a tan alpha kind of expression in the previous class. Yes or no? Have we used that?
Yes.
Yes. So what was that tan alpha? Actually, this is that alpha. Understood? Is this
Tan
clear to
alpha.
you?
Yes.
And what this tan alpha is equal to?
B sine theta by A plus B cos theta.
B sine theta by A plus B cos theta. This is the final expression that is being obtained by us. Yes or no?
Yes.
Okay, so this is the whole thing that the parallelogram law says. Don't take it. like this is the anything new. This is something that we had already learned, है ना? Because if we will shift the B, the B will come at this position, and then again you are going to draw this resultant only. So this is something that the resultant that I should draw after shifting it or without shifting it. Can you understand this?
Yes.
Okay, so this is not a big deal for us. This is the very easy part that we had already, I think, covered in the last class. But only the just I had not said all these words, the parallelogram law here. Yes or no?
Yes.
And what else after that we had discussed about?
Uh, Equilibrium of vectors.
Equilibrium of the vectors. Equilibrium of the vector. What does it says?
That A minus B is smaller.
Yes, we had actually seen what we had done. Actually, what we were doing there, that let me see that whether I'm having that or not. Or 23, to, I think, or 21 also. 20. I don't know where we had done that. Yes, this was the thing, I think, the last previous. Yes. So yes, we were having these slides only. Yes or no? We had derived that.
Yes.
After that, we were saying that is the three vectors can form a equilibrium. For example, if there is a 4 meter, 10 meter, 5 meter, can we form a triangle using it? Okay, so what we used to do, we had seen the maximum and the minimum of the range. We had already covered it. The minimum is the subtraction of the magnitude, and the maximum is the addition of the two vectors. Yes or no?
Yes.
For the minimum, what should be the angle between A and B?
180.
180. And for the maximum, what should be the angle between A and B?
0.
That is 0. Yes. After that, we had seen all these things, है ना? So we had already covered this. Okay. And after that, we had also seen that if the two vectors are so what should be the angle in between them? Okay. So we had actually covered all these things in the last class. Is this clear to you?
Yes.
Okay. So I had told you about the parallelogram law of vectors, and now and have you completed the last class homework that I had given to you?
Yes.
Okay, so you must have uploaded it over there. I'll check it the copy and return it to you over there only. Okay, so the next thing that we are going to see over here is that the subtraction of the vectors. Write the heading that the about the subtraction of the vectors. Yes, sorry for the interruption. Actually, now we are going to see the subtraction of the two vectors. Suppose that we have given the two vectors that let's say one is vector A and let's say take the another vector to be B. Okay, we had given the two vectors A and B. Now we'll use this parallelogram law only mostly. Most of the time we'll see this parallelogram law only. Now what is required by us is that we want the resultant vector R. But this time, what kind of the things we want? We want A minus B. What we want? We want A minus B. Is this clear to you? What our aim is to find out?
Yes.
Okay, so if we want the A minus B, so again we'll see it in two category. What is one? The one will be that the magnitude part, and another will be then we'll define the direction also. So actually, while doing the subtraction of the vector, see what we are going to do. You don't have to think it like that you are subtracting B from A. Right now, it is looking like that we are subtracting B from A. But what we'll do, we'll rewrite this expression in this form, A plus minus of B. Is this clear to you? That what we are going to do? We are going again to perform the addition only. Can you tell me that if this is minus B, this is plus B, sorry. This is the plus B vector. Can you tell me that how the minus B will look like?
Sir, I'm not able
Yes,
to hear your
is
voice.
it clear now?
Excuse me, sir. I'm not able to hear your voice.
Yes, Rasha, is my voice clear to you now?
Yes.
Okay, so actually I was saying that if this is the B vector that is given to us and we want to subtract the B from A, so actually instead of subtracting it, what we'll do, we'll add the vector minus B in A. Understood? Now tell me if this is the B vector that is given to us. This is the B vector that is given to us. Can you tell me that how the minus B will look like?
Opposite.
Opposite of that. I had just told you while talking about the negative vector. So minus b will look like somewhat like this, that it will have the same length as of b, but will have the opposite direction. Yes or no? This will be the
Yes.
minus b vector. So now what you have to do? You have to add just this vector and this vector. Is this clear to you? What we are going to do? We are going to
Yes.
add a and minus b. So how we are going to do? First of all, we'll take this a, suppose what we are going to do that first of all we'll take this a, and let's say that I'm just writing it over here, and then we'll take this b. Okay, and we'll just add it over here. How we are going to place the b? We are going to place the b in this position that the tail of a and b should coincide, so that we can easily find out the angle as well as the what else, as well as the, that we say the angle as well as the magnitude also. Okay, so is it in the now right in the right position? A and B are in the good position now to add and find out the even angle also in between them.
Yes.
Okay, but tell me one thing, that what is the actual angle between A and B? Okay, just a second, give me a second, it's an important call, I need to take it. Sorry for the interruption. Actually, somebody had stuck somewhere and they were calling me. So I need to take it. Okay. So this was the now actually just I'll start it from the very beginning that we had actually the resultant R vector. We need to find it out what it is. It is A minus B. Okay, but we used our brain and we decided not to subtract this. We actually are very much we are very good in addition of the two vectors. So what we decided instead of doing this particular operation to be of a subtraction, what we did R equals to A plus of minus B. We actually performed this particular operation. Now as there was the b, so there is the similar vector somewhere that is minus b. We don't care about it that what it is. If the two vectors are given to us, we can easily we can add it. Okay, so we are doing this particular operation. Okay, but actually what the thing is that we had a, the minus b will have the same magnitude but as of the opposite direction. The minus b will have the opposite direction. So as it is the plus b in that direction, so minus b will be pointing in downward direction. Is this clear to you?
Yes.
And for to the perform the addition, what which law we had used? Triangular law of addition or the parallelogram of law of addition?
Parallelogram.
We had used the parallelogram of law addition. And actually parallelogram and triangular both are the same. It doesn't vary a lot. But actually the positioning of the vector matters in both the laws. Okay, but we are using the parallelogram. The reason behind that, because we can coincide the two vectors the from tail to tail, and we can find out the magnitude as well as the direction at the same time. What we can do, we can find out the magnitude as well as the direction at the same time. Okay, so this is something that is it is something that we are doing here. Okay,
Okay.
so we had just did and we placed the so that we can do it one in one step only. We don't require to first of all find out the angle and then put it in the another orientation, find out the resultant. We use the parallelogram of law addition, and what it says that if you will complete the parallelogram, the diagonal will that what will the diagonal do? The diagonal will become the resultant. Is this clear to you?
Yes.
Okay, so the diagonal will look like somewhat like this. Yes or no?
Yes.
The diagonal will look somewhat like this. So we are very much good in that. But now actually for to find out this particular thing R, for to find out this particular thing R, just a second, Rasha, I again need to take it up. Sorry. Okay, so this is the R here. But now if we'll do the resultant R, how should I find it out? Now tell me one thing. What should I write inside the bracket, inside the under root?
A square.
A
Hmm.
square, okay, plus
Plus minus b square.
uh, what was the second thing actually? Tell me. What is the A and B? A and B are the magnitudes, Avalna. So what is the magnitude of A? That is A. What
A.
is the magnitude of minus B?
B.
It is nothing but B. So what should I write here? I should write the B square only. Is this clear to you? Can you understand this?
Yes.
Okay, because that's why I had asked you initially that what is AB? AB are the just magnitude. So what is the magnitude of minus B? It is nothing but B. Okay,
Yes.
because do the length changes if I place a minus sign in front of it?
No.
No, the only thing it changes is its direction, its orientation. So not orientation, actually its direction gets opposed of the initial vector. So a square plus b square. What the next should I write? 2ab and cos of. Now this is something that I need to think about that what should I place inside it? Yes or no?
Yes.
Acha, tell me, what should I place inside it? Should I place this angle that is somewhat I don't know about it? but this should be at that angle. Yes or no?
Yes.
That is alpha somewhat. I can say it as alpha. Yes or no?
Yes.
What is this alpha now?
The entire angle.
What it is, between which two vector this angle is?
A and B. A and minus.
A and B.
Minus B.
Angle between A and minus B. Is this clear to you? That this is the angle between A and minus B. But we are actually much comfortable in finding out the angle between A and B. So tell me, if minus B is looking like this, so do you agree that that plus B, let me draw it with some different color, that plus B will look somewhat like this only, but will be in this direction of the same magnitude. Yes or no?
Yes.
Okay, so if the what we used to represent theta for? We used to represent the theta for angle between the two vectors A and B. Yes or no?
Yes.
So do you agree from here that theta plus alpha will be nothing but 180?
Yes.
So can I write alpha like 180 minus theta?
Yes.
So what the next thing that I can write here? See, this formula is completely correct. There is no issues with this. Okay, this is completely full-fledged formula and no amendment is required in this. But we are going to write it in a somewhat a simpler way. We are trying to write found a somewhat simpler way. That's why we are doing all these things. So and actually I should not write R bar here. I should write simply R. The reason behind that, because it's the magnitude, not the complete vector. Okay, so it will be R equals to under root of what it will be, a square plus b square plus 2ab into cos of 180 minus theta. Should I write it like this?
Yes.
Now this time what is the theta? What is the theta here?
180 minus alpha.
What is the theta here? What is the theta representing to us between the angle between which two vectors?
A and B.
Yes, it is the angle between A and B. It is the angle between the two vectors that were given to us. Minus B was not given to us. We had generated it. Understood? Why I am trying to replace the alpha? Because alpha is the angle between two vectors in which there is one is minus b, which we had generated it. The question had not given to us. The question had given to us only a and b. Is this clear to you?
Yes.
Okay, so do you actually? I should tell you here that cos of, actually in class till class 10th we don't used to study this property, but right now we are studying it, and I should like I had given you the value of sine 37 and sine 53. Yes or no? Similarly, I am giving you one more formula about the trigonometric angle, that is cos of 180 minus theta. It is nothing but minus of cos theta. Is this clear to you?
Yes.
I should, with this particular thing that we are going to use here, but with this I would like to give you some more, so that if it comes anywhere else in our course, so we should use it immediately. Okay, I will give you cos of 180 plus theta also. Cos of 180 plus theta is still minus cos theta. Is this clear to you?
Yes.
Okay, and sine of 180 minus theta is sine theta. Okay, and the fourth thing that we should see here is that sine of 180 plus theta is nothing but sine theta, sine minus sine theta. Okay, can you remember all these four? Although we are going to use only this first one, but I am giving you because with the time we'll get to know about it. We'll get see the complete proof also of this. But for the timing, I'm just telling you here. Okay, so that we can move it above. Okay. So
Yes.
what the resultant will become here? It will become r equals to a square plus b square plus 2ab and and minus of cos theta. Yes or no?
Yes.
Is this clear to you? If I place this minus sign outside, it will become r equals to under root of a square plus b square minus of 2ab cos theta. Is this clear to you?
Yes.
So this is the expression that we had obtained for the subtraction of the two vectors. What is our r is the resultant of the subtraction of the two vectors. Yes or no?
Yes.
And tell me one thing that what is a here? You should know about everything. What is a here?
Magnitude of vector.
Magnitude of a vector. And what is b here?
Magnitude of vector B.
And what is r here?
Magnitude of resultant vector.
Yes. What is the theta here?
Angle between A and B.
Yes, this should you should know about angle between a and b. Angle between a and b. Okay, is this clear to you?
Yes.
So this is about the subtraction of the two vectors. Now you are now I think we should move ahead, and this was the topic that we had seen about the subtraction of the two vectors. Is this clear to you?
Yes.
So should we move ahead with some different topics?
Sure.
Okay, I want that I think I should give you some questions over here. If I'm having, let me see that if I'm having some vectors or some questions over it or not. Okay, actually, I have the question, but for that, I need to give you some formulas over here of the trigonometry. Okay, like I had given you the four formula here, I'm giving you the fifth formula here. If you ever get to use that, so just use it. Okay, what it is sine theta equals to 2 times of sine theta by 2 into cos of theta by 2. Can you remember this formula?
Yes.
Okay, the next formula that I'm giving you over here is that 1 plus cos theta. See, these are all the mathematics that is required in the physics. And these all formula you will learn in a very depth in mathematics. But for right now, I'm giving you, and I'll make you assure that yes, this is the correct formula. Okay, but for that, actually,
I am not
I
a mathematics.
yes, sorry.
I am not a mathematics student, sir.
Oh, you are not a mathematics friend. Still, no need to worry about it. I'll give you the essence of this formula that that you are studying it correctly. Okay, but but actually these are all the things that you used to cover it in the mathematics in very detail and in very much depth, even a lot other than these formulas also. Okay, but for the time being, I'm just giving you the actually let me write here. 2 times of sine square theta by 2. Can you see all these three formulas? Yes or no? Because this will be used in the physics while solving the questions, while doing the simplification. Can you see this?
Yes.
Okay,
Yes.
so just okay, I had divided it in a very bad way, but try to manage with this. Okay, so these are the three formulas that we see. Okay, let's see the first one. Let's see the first one. Put the value of theta to be 60 degree. Put the value of theta to be 60 degree. What will I get? I'll get the sine 60 to be at one side. What is the value of sine 60?
Do 3 by 2.
Root 3 by 2. Okay, now tell me one thing. On the RHS side, what will I get? I'll get 2 times of sine of 60 by 2 into cos of 60 by 2. Yes or no?
Yes.
So what will be here in the inside sine?
30.
That will be 30. And what will be here in the cos?
30.
That will still 30. So 2 times of what is sine 30?
1/2.
That is 1 by 2 into what is cos 30?
Root 3/2.
Root 3 by 2. So can you see the if we'll cancel out the 2 from 2 and you will still get the resultant to be equal to 3 root 3 by 2. Yes or no?
Yes.
So do you agree that actually for to remember the first one, what you have to do? See, whenever you are finding out the sine theta and you need to halve the angle, this is called the doing the half of the angle. What we call it? This is the property of doing the half of the angle. So if we have the sine theta, we want to do the half of it. So what you have to do? You have to take the half of both sine and cos, sine and cos, and multiply it with 2. Can you now remember it?
Yes.
This is called the half angle property. Okay, these are all the half angles, half angle property. Okay, so is this clear to you? Sine theta equals to 2 times of sine theta by 2 into cos of theta by 2.
Yes.
Similarly, what the next is that remember this, that if you need to do the half of the half of this angle cos of theta, half of this particular angle. So what you actually need to do, you need to do 2 times of cos square theta by 2. You will, if you are taking the cos, subtract it with -1, and cos of, actually just write it in the reverse way only, then only you will be able to understand it. 1 plus cos theta equals to 2 times cos square theta by 2, and 1 minus of cos theta is nothing but 2 times of sine square theta by 2. Okay, you can check out the this is also true by just putting the value 60 degree instead of theta. If you'll put the 60 degree instead of theta, what will you get in the LHS? 1 plus, yes Rasha, what will be the cos 60 here?
1/2.
1 by 2. So that will be 1.5 or 3 by 2, sorry. You can write it also 3 by 2. Yes or no?
Yes.
And instead of inside of RHS, if you will do it, what will you get? 2 times of cos square of 60 by 2, that is 30. Yes or no?
Yes.
So what are you going to get? 2 into what is cos 30?
1/2.
Cos 30 is 1 by 2.
3/2. 3/2.
Root 3 by 2. If you'll do the square, what will you receive? 3 by 4.
Yes.
So if you just cancel out these two things, will you still get the 3 by 2?
Yes.
So can you see that 3 by 2 is again coming out to be the same? And similarly, you can check out the this one also. Okay, is this clear to
Yes.
you? So just
Yes.
remember all these things. Okay,
Okay.
okay. So should I give you the give you one question?
Sure.
Okay, you write the question that if two vectors having the same magnitude, if two vectors having the same magnitude, same magnitude p. Okay, this time the two vectors having the same magnitude p, having an angle theta are added, are added. They are the two vectors. We are adding them. Both having the magnitude to be same, that is p, and the angle between the two vectors is theta. Okay. Then find the magnitude. Find the magnitude of resultant vector. Did you understood that what the question is saying here? Yes, Rasha, did you
Yes.
understood that what the question is saying?
Yes.
Okay, so we have the two vectors and that are something like this. Both are having the same magnitude p. Yes or no?
Yes.
Both are having the same magnitude p. So how the resultant will look like?
The diagonal of the parallelogram.
The diagonal of the parallelogram. So it will be somewhat like this. Okay, so this is the resultant R vector. Okay, this is also P and this is also P. The magnitude of both the vectors are P. And where should I mark the theta here?
Angle between P and P.
Yes, so this is the angle theta here. So find out the R, what it should be.
I'm not able to get an answer.
Okay, so you must have reached to a particular expression of the R, what it is.
P square plus P square plus 2 P into P into cos theta.
2p square into cos theta. Is this yes or no?
Yes. Yes.
So this is the final answer actually. After this, you are just applying the mathematics. Let me show it to you. That's why I told you all those formulas because student used to do the physics, but they used to get stuck in the mathematics. See what the p square plus p square will be equal to? That will be 2p square plus 2p square
Yes.
into cos theta. Yes or no? You must have reached to this particular expression also.
Yes.
Can you take out the 2p square from the denominator from this to be common? What will you get inside it?
1 plus.
Yes or no?
Yes.
Is it looking like a good expression 1 plus cos theta?
Yes.
So from what we can replace it?
1 plus cos theta equal to 2 cos square theta by 2.
Yes, that is 2 times cos square theta by 2. Is this clear to you?
Yes.
So what will you get inside the inside the under root? You will get 4 times p square into cos square theta by 2. Yes or no?
Yes.
And what will come out of it?
2P
2p and cos
cos
theta by
square
2.
cos theta.
Instead of cos square theta by 2, square will be cancelled out, na? If you just write the cos square theta something like this, will it become cos square cos theta only?
Yes.
Yes or no? Just do it for
Yes.
random angle A, or instead of random angle, let's choose alpha. So it is cos alpha. So this is the final answer. Yes or no?
Yes.
So this is the final thing that you should know about. Now the next thing that somebody can ask you is that where this R will be, what will be the angle it will make with any of the P? What will be the angle it will make with any of the vector? So what the somebody is actually asking is that what is this alpha? Yes or no?
Yes.
So if somebody is asking about this alpha, so what you should say about what can be this? Can you find out the tan alpha? What is the tan alpha?
B sin theta by
B sin theta by
A plus B cos theta.
A plus B cos theta. Now tell me that instead of B, I should write P only.
Yes.
So P sin theta divided by uh, P plus P cos theta. Yes or no?
Yes.
So what the next is? What the next thing comes into your mind?
Take P outside.
Take P outside. So in the numerator, I'll get this expression. In the denominator, what will I get? P into 1 plus cos theta.
Yes.
Do I need to cancel P from the numerator and the denominator?
Yes.
What will the result that I'll obtain here? That is sine theta divided by 1 plus cos theta.
Yes.
So what do you think the next thing that we should do here?
2 cos square theta by
Yes,
2.
exactly. So sine theta divided by 2 times cos square theta by 2. Is this clear to you?
Yes.
Can we change the numerator also in the half angle? If we want to halve the angle of the sine, what we actually used to do was, do we used to take the sine and the cos as well and multiply the expression with the 2?
Yes.
So what it will become?
2 sin theta by 2 cos theta by 2.
Cos theta by 2. Uh, yes, cos theta by 2. Whole divided by 2 times cos theta by 2. Let me write the cos square theta to be like this. Cos theta by 2 into cos theta by 2. Yes or no?
Yes.
And cos theta by 2. Okay, what the next thing that comes into your mind?
Cancel theta by 2.
This will be get cancelled out. What will remain here? Should I cancel the 2 also?
Yes.
Yes. So what the thing that you can think about right now? Sin theta by 2 divided by cos theta by 2. What it actually becomes sin by cos?
Sin by tan theta by 2.
That is tan theta by 2. Yes, you're going very nice. That's it. Tan alpha is this. What is then alpha equal to?
Tan square theta by 2.
What this alpha is equal to? Can we cancel out actually the tan from both the sides?
Theta by 2.
Only theta by 2. So this is the thing final, that it is making an angle of theta by 2 with one of the vectors. Is this clear to you?
Yes.
Yes, nothing but theta by 2. And actually, we are, if the two sides of the parallelogram are equal, do we used to get the resultant of it to be in exact midway? Yes or no?
Yes.
So it is
Yes.
somewhat like this. Although if we had used just the mathematics, then we had just proved this. Is this clear to you?
Yes.
So this is the final thing that we had obtained. Suppose if I ask you the same thing, but this time instead of taking this to be the addition of the two vectors, what I'm doing here is that I'm taking the subtraction of the two vectors. So what do you think that we'll obtain here? Let me copy paste it over here so that we can save some time. Okay. So let the question be like this. And if two vectors having the same magnitude, P having an angle theta are subtracted this time, then find the magnitude of the resultant vector. Then try to do it at your own while I'm drawing over the expression or the figures here. Try to do it. A is somewhat this and B is somewhat this. This time we'll use the formula that we had derived today. That is, instead of plus cos theta in the end, we will take the minus cos theta because we are subtracting here. Yes, did you got something?
2p square minus 2t square cos theta.
Okay, you are saying r equals to under root of, first we'll do p square plus 2 times p square, not plus, this time minus 2p square into cos theta. Have we got this?
Yes.
After that, should I do it a little faster way? I'll take 2p square common, I'll get 1 minus cos theta. Yes or no?
Yes.
What's the next step should I do? 2p square into
2p square into uh, 2 sine square theta by 2.
2 sine square theta by 2. Yes, nice. After that, what the next thing should I do? Under root of, what will I get
And
here?
4p
4p square sine square theta by 2. Yes, what's the problem in this? After that, what will come out of the under root?
4p sine theta by 2. 2p sine theta.
4p, 2p sine theta by 2. Yes, so this is the final expression of the r that we had obtained here. Okay.
Yes.
See, how I'm deciding that this is the final exception. Actually, whenever you had answered the thing in terms of the question that is being provided to you, that is considered as the final expression. Okay, so actually that we had got here in the first step only. We had represented the r in terms of p and theta that was given to us in the question, but we had just simplified it after that. So actually, it is the mathematics after that we are applying here. Okay, so that is the thing. Okay, after that, what will be the tan alpha here? What will be the? Acha, tell me one thing. That where should I draw the r here? Should I draw it like this? That it will be one will be this, another one will be this, and the R will look somewhat like this.
Yes.
Will it look somewhat like this?
Upside down. It will be upside down.
Yes. Just place a big cut over this, and then what we'll do, we'll take the first of all, we need to invert the second vector. Okay, if we are taking the P to be like this, one is given to us like this, another one is given to us like this. This is not the final vector who we are adding. We are actually taking the negative of it. That will be somewhat this of the same magnitude. And after that, then we are adding it up by using the parallelogram law, and this will become the resultant this time. Okay, so actually this is the resultant. Now, what will be this angle alpha if we are considering it?
Alpha theta by 2.
It will be uh, what it is b, and instead of b should I write it directly p sine theta
Yes.
divided by, okay, tell me one thing, while, okay, we can see it over here also, p sine theta divided by a plus b cos theta. Yes or no? Instead of a and p, what should I do? I should take p plus p cos theta. Yes or no?
Yes.
Okay, tell me one thing, that previously theta was the angle between the two vectors. Yes or no?
Yes.
This was the formula when the theta was the angle between the two vectors. Yes or no?
Yes.
This time, what is the angle between the two vectors? Is it theta now? This time,
No.
this is the angle between them vector. That is 180 minus theta, because theta is this angle.
Yes.
So instead of theta, you should replace it with 180 minus theta. Yes or no?
Yes.
So what will be the final expression this time? B times of sine of 180 minus theta divided by A plus B times of cos of 180 minus theta. Yes or no?
Yes.
So now tell me that What will be the expression final? That will be P. And what should be 180 minus theta? Sine of 180 minus theta is?
Sin theta.
This is directly sine theta divided by P plus P. And what is cos of 180 minus theta?
Mm, minus cos theta.
Minus of cos theta. Okay, so what will I get expression here? That is sine theta by 1 minus cos theta. Yes or no?
Yes.
Do the similar substitution and try to find out that what the alpha will be equal to. First of all, you will do the half angle of sine theta. Yes or no? And the
Yes.
denominator also. If you'll do in the numerator, what will you get? Now I think you had just memorized it correctly. That what it will become?
2 sin theta by 2 cos theta by 2.
Sine theta by 2 cos of theta by 2. And whenever there is the subtraction, should I do I use to get sine or cos?
Sine. 2
Sine.
sine
So
square.
I should place 2 times of sine square theta by 2, and I should write it like this. Okay, so that it will be easier for me to cancel it out. Okay, is this clear to you?
Yes.
So what it will be? This will cancel out this, and 2 will also cancel out this. What will I get here?
Cos theta by 2 by sin theta by 2, which is cot theta by 2.
Cot theta by 2, and this is tan alpha. Can I now do any kind of thing here?
Well,
Now it is tougher for me because one side it is tan, another one side it is cot. So simply do it like this. Just take the tan on another side and write it like this. Tan inverse of cot theta by 2. That's it. Leave the things over here only. This will not be asked to you because you are not a mathematics student. You can just leave the answer here only. Okay, is this clear to you?
yes.
We can apply the more mathematics over this and we can get a very much simpler expression also, but not to do that, and not it is not required to by you to do so. You can just leave the things over here. Okay,
Yes.
okay, that's it. So this was the thing that you should know about for the simplification of the two vectors. Is this clear to you?
Yes.
Should I give you some more question? Let me see that am I having one more good question, then we'll move on to the another topic. Yes, I am having one. Okay, write the question that what the
May I know
question
how
says.
long this class is?
Yes, sorry.
May I know how long this class is?
This is till 8. Okay. Indian time. Okay.
1.5 hours or 2?
1.5 hours. It is not being told
Okay.
to you.
Um, I don't get the message of how when it ends.
Okay, you didn't got that message. Actually, this is 1.5 hours class. Okay.
Okay.
Are you having any other class also?
No.
Okay, so no issues with that. Two vectors have of same magnitude. A combines the two vectors are having the magnitude A combines to give a resultant combines to give a resultant of magnitude A. Find the angle between the two vectors. Angle between two vectors. Understood what is being question is asking here? Question is saying that two vectors are there and the magnitude of both the vectors are A, and they're combining to give a resultant, and the magnitude of the resultant is also A. Then find the angle between the two vectors. It is being asked to you. Okay. And one more information that I'm giving you over here is that if cos theta equals to -1, that means theta equals to 120 degree. Oh, sorry, not -1, it is -1/2 actually. Na? This is the mathematic information that I'm giving to you, that cos theta is equals to minus of 1/2. The theta will be equals to 120 degree. Okay.
Okay.
Actually, we used to see all these trigonometric things in the basic mathematics course that we will do once we'll end up this chapter, particular vector. Okay. So that's why this is the little information that I'm giving you over here right now. But there you will get a complete full-fledged things together. Okay, right now I am just giving you, and actually I'll suggest you that as we are going to do this long course, so you must write all this as you are not a mathematics student now. That's why I'm just suggesting you that you must write all this mathematics in you should keep one or two starting pages for this mathematics, and you should write all those things over there. Okay, so that if any time you require anything, you should get it over there on the one or two single pages. Okay, so just keep on writing it over there, as it will keep on increasing slowly and slowly, as I'll keep on giving you the little information every time.
Okay.
Okay, start solving it. Once you had attempted it at your side, just let me know, then we'll do it here. This is one of the very good question. This is one of the very good question. Yes, did you got something?
A/2a equal to cos theta/2.
You are getting an expression. Okay, you are saying that a/2 equals to
A/2a.
a/2a.
Yes.
Like, where should I write it?
It's like a equal to 2a cos theta/2.
A equals to 2a cos theta/2. You are saying it like this?
Yes.
Okay. So actually you are a little closer, but not completely. So let me see here. Right now, what I'm thinking about, that we have the two vectors. Suppose this is the vector A, and actually both are having the same magnitude. So let this vector be A, and this is also A. If I do the resultant, then also I'm getting the same vector A. And this is something beyond my imagination right now. How can, if I'm adding up the two vectors and still I'm getting the same answer? Can you imagine it? That you are having the two vectors, you are adding them up, and you are still getting the same answer. Can you imagine it? Can you give me an example of this kind of orientation of the vectors?
No.
Right now, I'm also very like unable to think out of like this. So let's see that what happens, that how we can find out. So suppose that the two vectors are given to us. Let the two vector be in any orientation. I don't care about it. But I know the resultant of the two vectors is that is under root of, and I'm doing the combines, magnitude of A combines to this. Combines mean we are doing the addition. So magnitude A to give a resultant vector A. Okay, so we are combining the actually two vectors. So we are doing A square plus B square plus 2AB cos theta. AB cos theta. So actually we have this, and both vector, that is magnitude of A is equals to magnitude of B, and that is equal to A only. Yes or no? It is given to us in the question, and it is actually also equal to the magnitude of R. So I'm just put an arrow over all the things that is equal to the R. So I'm just placing it over here, that A is equals to under root of A square plus A square plus 2 times of A square into cos theta. Yes or no?
Yes.
Acha, tell me one thing. If I somehow get to know about this theta, if I get to know about this theta, do you agree that uh, uh, I can then imagine that how those two vectors will be placed? Yes or no? Then that will become convert into the imagination, because if this is A, I need to draw another vector of same as this length, but with an making an angle of theta with this one. So it will be somewhere anywhere in this particular here, but I should get to know about this particular theta, that what the theta is actually. Yes or no? So
Yes.
actually, we are actually in search of this theta only. So what we are going to do here, that keep the under root over here only, and what we can see here, that 2A square plus 2 times of A square into cos theta results in this A. Yes or no? So
Yes.
what the next thing is required to us? That is the very easy one. That is 2A square into 1 plus cos theta. Is this clear to you?
Yes.
This is A. Now, what the next thing we can think of? Can we replace this 1 plus cos theta with anything, or one thing that
2.
I'm thinking of is that to remove this under root on the another side by squaring on both the sides. Yes or no? Squaring on
Yes.
both the sides. This is the method of removing the under root, squaring on both the sides. If I do the square on both the sides, what will I result in? A square equals to 2 times of A square into 1 plus cos theta. Yes or no?
Yes.
So do you agree that if I divide this A square divided by A square equals to 2 times of 1 plus cos theta? Yes or no?
Yes.
What will be there in the LHS? The A square will cancel out this. I'll
1.
get 0. I'll get 0.
1.
Yes, we'll get the 0. I used to see a lot of students doing this mistake. That's why I had committed it over here. That's why I'm asking to you. 2 into 1 plus cos theta, it will be this. Then do you agree that I should divide it by 2?
Yes.
1 by 2 equals to 1 plus cos theta. Yes or no?
Yes.
The next thing is 1 by 2 minus 1 is equals to cos theta.
Yes.
Will I get minus 1 by 2 on this side and cos theta on this side?
Yes.
Will I get cos theta equals to minus 1 by 2?
Yes.
What the theta is?
120 degree.
120 degree. And this is the something now which I can imagine of. What the question is saying, that if you take a vector like this and you take another vector of the same length, but this time the angle between them should be not be 90, this is somewhat 90, and this will be somewhat 120. If you keep the angle between them to be 120, you will get a resultant vector that will be, you will obtain it by completing the parallelogram. And here we had just completed the parallelogram, and if we join the this particular thing, this particular thing will be somewhat the R, and it will have the same magnitude. Yes or no?
Yes.
So what we have actually here is that A equals to magnitude of R. magnitude of r is equals to a. Is this clear to you? And what this complete angle is actually equal to 120 degree. Okay. Can you tell me
Yes.
that how much this angle will become?
60.
Yes, that will be somewhere 60. You can find it out using the formulas also. Okay. You will get the answer by putting the things in the formula also. See, I can show you here that if you have two vectors, but for that actually you need something that I should tell you here, that the value of sine 120 degree, the value of sine 120 degree is nothing but root 3 by 2, and the value of cos 120 degree, how much the cos 120 degree is?
Negative 1 by 2.
Minus of 1 by 2. Yes. Okay, so you should know about this also. Okay, so let me solve it over here, that how the I'll obtain the angle between r and this. Or let's say that we don't know about it. It will be tan alpha. What is the formula for tan alpha? Is it b sin theta divided by a plus b cos theta?
Yes.
Now tell me that the value should I take here?
A.
Sin of
120.
whole divided by a plus a into cos of
120.
what will be I'll get in the numerator?
A 3 by 2. A into 3 by 2.
Root 3 by 2 into a and whole divided by a into 1 plus cos of 120, that is
Negative 1 by 2.
what the expression that I'll result here is.
Here we cancel A.
Yes, we can cancel out the a. What else will we get? What will be the final answer that I'll get from here? Tan alpha is equals to,
Root 3.
yes, that is root 3. How I am getting it? Root 3 by 2 divided by 1 minus of 1 by 2, that will nothing but 1 by 2. And I can cancel out this 2 and 2. Okay, remember this thing, that numerator, if I get a fraction in the numerator, I get a fraction in the denominator. You can cancel out the denominator from denominator and numerator from numerator if it is, okay, if it is cancelling out. For example, 2 and 2 are cancelling it out, so I can do it directly. So I'll get the root 3 here. So what the angle alpha should be equal to? What the angle alpha should I choose for to get the answer to be root 3?
60.
That is 60 degree. And here also I had got that 60 only. Yes or no?
Yes.
And actually what is happening here, the actual visualization I want to tell you here is, the actual visualization that I want to say you here is that if you take a vector A like this, if you take a vector A like this, and you take another vector of the same magnitude, somewhat like this, somewhat like this. So, what will be the resultant of these two vectors? Will it be this vector joining from the initial tail to the final head? Yes or no?
Yes.
So,
Yes.
from this particular thing, can you say that A plus B is becoming equal to the this vector C?
Yes.
A plus B is becoming equal to this vector C. So what it is actually, this is actually forming a equilateral triangle. That's why the two sides that you were given was having the magnitude as A. What you had given, the vector magnitude of A and B was given to you as A, and the resultant all was also coming out to be A only. So this is why the reason that the resultant is making an angle of 60 degree here, and this particular B I cannot find out the angle between B and A now. Can you understand it? Why I can't do so right now?
Yes.
The reason behind that?
Because the figure is not proper for
Yes. So
finding out.
what I actually need to do?
Move the B.
Move the B or extend the A. Both the things will work here. Yes or no?
Yes.
If I extend the A, I'll get this angle will be there in between A and B. Yes or no?
Yes.
If this is the angle that is 120 degree, so this will be the angle that is 60 degree, and this will be also the angle 60 degree, and this will become a equilateral triangle. Yes or no?
Yes.
So this was actually the question was talking about this particular orientation of the vector. Is this clear to you?
Yes.
Okay, so we should start the next topic over here, that is the unit vector. This is one of the very, 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 very important the thing that we are going to start with. That is the unit vector. Unit vector, what it actually means. What is the meaning of unit?
1.
Yes, that means it will have a magnitude equal to 1. Equal to 1. So any vector which is having a magnitude 1 can be called as a unit vector. Is this clear to you?
Yes.
Okay. Now tell me one thing, that its magnitude is fixed. You can't change the magnitude. Okay. Unit
Yes.
vector magnitude is fixed. You can't change it. You can always only take this thing, that is the magnitude, to be 1 only. You don't have any other options. You can't take it 2, 4, 6, 8, 8.5, 9, 10, 12. Nothing. You have to take it 1 only. So what the vector have actually two things. What are those two things that the vector actually have?
Magnitude and direction.
Magnitude and direction. If you had fixed the magnitude and it's not in your hand, what can you use this particular vector for?
Direction.
Yes, so it is used it is used to give directions. Is this clear to you? That it will be used to provide the directions only, because the magnitude is not in your hand. You have already defined it like that, that it is that it is having the magnitude to be 1. So now see that how to find this out. Our next thing is how to find unit vector. So how to find the unit vector? Suppose we have a vector like this. Okay. Can I do the scalar multiplication with the vector? Yes or no?
Yes.
What the scalar multiply used to do actually with the vector? What changes it used to make in the vector? If I multiply a vector with with some quantity, let's say if I'm having a vector and multiplied it with 2, so what it will cause with that, the new vector will be?
Increase the direction.
It will increase the magnitude actually. It will increase the length.
Yes.
Yes or no? If it was initially having some length, if I multiply it by 2, now it will have a double length. Yes or no?
Yes.
See it where you had written. Do it changes the magnitude?
Yes.
And do it changes the direction also?
No.
No, it may change the direction. See what you have written there.
It may.
Yes or no?
Yes.
It may change the direction. It may change the direction depending over the scalar that we are choosing. If the k is greater than 0, it will not change. If k is less than 0, then it will change. Yes or no?
Yes.
That means we can actually reduce or increase. We can actually increase or decrease the magnitude of the vector. Yes or no? By just multiplying it with some constant. Is it
Yes.
clear to you? So
Yes.
what we are actually going to do, we are going to multiply it. See, if I have given a vector, let's say 10 Newton in this direction. Okay. So what will I do for to find out the unit vector? I'll just divide the vector with its magnitude. For example, 10 Newton was given in the east direction. Let's say 10 Newton is given in the somewhat in the east direction. I'll just divide this with 10 Newton with 10 Newton. Now what will I get? I'll just get 1 Newton in each direction. Yes or no?
Yes.
So this is how I actually use to find out the unit vector. So what actually I need to do for to find out the unit vector, I have already I have one vector. I have to just divide it by its magnitude. Is this clear to you?
Yes.
And actually we used to represent the unit vector by putting a cap over the variable like this. Is this clear to you?
Yes.
We used to represent it by a cap. Okay, so this will be something that is a cap. Is this clear to you?
Yes.
Understood. Now, for example, what is the use of this? Suppose we have a vector that is, let's say, a vector is given to us. A vector is given to us. Now we want a vector uh, of two times of a. Okay, and actually it is just used to specify the direction. Now the a cap will become what the a cap will look like. A cap will look like the same vector, but this time it will be having the magnitude as 1. Is this clear to you? Suppose this was having the magnitude as whatever it is, but if I'll find out the a cap, it will be having the magnitude to be equal to 1, and it will point in the same direction as the a. Is this clear to you?
Yes.
So, and after that, what uh, actually I have to do for to find out the unit vector, I just need to divide it by the same vector by its magnitude actually. Is this clear to you?
Yes.
Okay. So this was the thing, and let me see. Let me ask you one more thing. And what it actually used to do. Suppose I want a vector to be of magnitude 10. I want a vector to be of magnitude 10 in the direction of A. What will I do? I'll just take the unit vector A cap and I'll multiply it with 10. Understood? This is the actual use of the unit vector that I can take of any magnitude. Now, what I actually want is that I want a vector of 100 magnitude and it should point in the direction of A. I'll just take it like in this way. Okay, what does this A cap mean? That it is pointing along the A direction. 100 means it is having the magnitude as 100. Okay, is this clear to you?
Yes.
So I think we should keep it till here only, and we'll have then the next class after this session. So if I'll assign you the homework also today, just solve it. And if you are having any kind of question in the today's class, then you must ask it, and you must also write all these formula once more. Okay, ask for the this PDF. Once the class gets over by the operations team, they'll give you the PDF of this particular notes, and just see the all the trigonometric formulas that I had written here. Okay, not to actually I'll say you very originally. I'm not that kind of people that I'll say that no, no, you will get to learn everything slowly, slowly. You have to memorize it. The end goal is that if I ask you what is cos of 180 minus theta, you should answer me minus cos theta. That is the only goal that you have right now. As you are not a mathematics friend, otherwise you will have a problem in the physics. I'm just speaking you very openly. That's why that's why I'm giving you very slowly. I'm giving you the formulas in a very slowly manner so that you should grab it very easily. I'll not make it hectic for you anytime. I'll give you very slowly and I'll give you the complete content. Okay.
Okay.
So just let it keep till here only. If you have any doubts in the today's class, you must ask it.